Okay, let's talk about stuff. All right, let's get started. I swear, the music comes off and I know lecture's got to start, and then I suddenly forget how to type, trying to crank that message out real quick. Let's talk about stuff. So right now, we had the task 4 expected deadline this morning. Is the big event that's happening in the course, so to say. And there's a bit of chatter, a bit of discussion about this. So I want to talk about task 4 a bit before we get back into inheritance. I saw somebody asking for stats. I usually don't share stats too often anymore, not for any particular reason, but for this one I'll share some. The deadline this morning, the expected deadline, 123 students did meet the expected deadline for task 4. So there's no issues in Autolab. The Autolab's not just automatically failing everybody. There's no problems there. That's a quarter of the entire class. 50%, about 250 students. Just a reminder, there's 5 sections, so a little over 500 students across all sections. And I'm talking the class as a whole, not just this section. About 250 students submitted. Half the class didn't even make a submission before the expected deadline. So about half of the students who made an attempt at the expected deadline did meet that expected deadline. So there's a lot of chatter, some upset students, some Piazza posts, chat in Discord. Some students are rather upset. I want to say that it's not a huge widespread issue. It's not like 80% of the class is trying and failing it. So I want to start with that just to give you all a perspective of where the entire class is at with task 4. And I want to give some tips for it, is of how to I don't know, just some tips for task 4. So let's talk about them. I had office hours yesterday, and I've been hearing from again, Piazza, Discord, the TAs. They bring things to my attention as well. So I just want to talk about some things that are common issues that I've seen for task 4, which will hopefully get you through. And by the way, there's no sugarcoating it. Like, task 4 is a beast of a task. There's a lot going on with this one. So I understand a lot of what's going on here is just that task 4 is, taking a lot of your time, to put it lightly. So to help you out, do not test undefined behavior. I've seen this quite a few times. If you're testing something that's not defined in the homework doc, what are you testing? Is my big question. I like the line of reasoning, things like that. So I'll just point out the example. It's more clear what I'm talking about through an example. I like the line of reasoning. I see a lot of students testing this Bayesian average of something like 3, -2, adding 3 ratings of -2, and then computing the Bayesian average and writing a test case for that. But what's the expected output when this is the input? What do you expect the method to do? The homework document doesn't say. The homework doc doesn't say if you are trying to add ratings that were invalid when we wrote the song class, if you're in the ratings class. If you're adding invalid ratings according to that, should they be counted as invalid or not? In the ratings class, we said the rating has to be from 1 through 5. So anything outside of that range shouldn't be considered a valid rating. So I have students testing a test case like this, and then expecting the method to return just the straight-up average of the ratings and treating the additional ratings as invalid since they're -2 and not adding any ratings. I do like that line of reasoning. I like the way you're approaching the problem and thinking it through. Unfortunately, in this case, since there's no verbiage in the homework doc for Bayesian average rating of what should happen if the ratings are invalid according to the ratings class, like the ratings class was separate from the Bayesian average rating, since there was nothing defined there, we don't actually know what the behavior was supposed to be. And technically, if you got your lawyer hat on and did some careful, some fine reading, really picked apart the sentences of the Bayesian average method from the homework doc, this should add 3 ratings of -2. There's nothing that said invalid ratings aren't allowed for this method. This is a lot different, the reasoning behind that. This is a lot different than the ratings class in the reviewer class, where we don't want to allow our users to add invalid ratings. We don't want a user adding a rating of 100 on a song that they really like. But the Bayesian average rating method, that would be controlled by us. This wouldn't be called by our end users. So we might want to go out of bounds. We might want to add extra ratings of -2. That's the reason it's set up like that. But the homework doc could have been more clear about that. So this was left as undefined behavior, and you should not test undefined behavior. And that's not just a 116 thing. That's a throughout your career thing. If there's if there's functionality that's not spec'd out in the spec sheet, hopefully, some places you work at won't do this, but hopefully you're working at a place where you'll get a spec sheet. They'll talk to the customer, negotiate what the software you're building should do, and you'll get a spec sheet with all the stuff that it should do. And then you'll have more technical documents that are generated by your team and document how the software is supposed to work. Anything not defined in those documents shouldn't be tested because different implementations might do different things. It's up to the developer how to react when you get not invalid, but when you get undefined behavior in a method, behavior that's not defined by any docs. Inside 116, it's the homework doc. That's our spec sheet. If it's not defined in the spec sheet, it's undefined behavior, and just don't test it. So I do like that students are looking for the edge cases, but in this case, it wasn't an edge case. It was undefined behavior. Very technically, it was defined, and it shouldn't count these as invalid ratings. So they were failing auto lab because they were expecting the average to be returned. My correct solution would just straight up add 3 ratings of -2 and compute the math that way. So undefined behavior, don't test it. And any methods that don't exist, I saw this one time in office hours. I don't know how common this is, but it comes up every semester, so I assume it's happening this semester too, that I just haven't seen more of it. Do not test methods that aren't defined in the homework doc. So don't test methods that are undefined behavior. I saw this. Somebody had playlist.getComparator. They wrote a getter method for the comparator. They were calling that getter method and expecting it to return the comparator that they gave the constructor. Again, I like the thought. I like the reasoning here. You want to make sure that the playlist got the right comparator from the constructor. But this method doesn't exist in the homework doc, which means it's not going to exist in the solutions in Autolab. So when you have a test testing the getComparator method that is never mentioned in the homework doc, and you go to submit, you're going to get failed the correct solution because that method doesn't exist. You're trying to call a method that doesn't exist. Program crashes. The test fails. It just doesn't work. So if it's ever a method that you created on your own volition or a method that you chose the name of, you can't test that method because it won't exist in other solutions. And again, that's not just a 116 thing. That's a whole career thing. If you're testing something that is implementation specific to the way that you solve the problem, and you're testing that's a bad test. Because now, say somewhere down the road, somebody goes in and rewrites your code. They implement the spec in a different way. Maybe they're trying to speed it up, make things more efficient or something. They implement things in a different way that doesn't have a getComparator method, which is completely within their right to do. They run your tests, and the tests say you failed, even though you implemented the spec sheet completely correct, even got a speed up, more efficiency and everything. The test says you failed because you didn't do it the way that the original developer did it. Don't write tests that are specific to your implementation, which would be this thing. And both of these are innocent enough. There's nothing wrong with doing these things. Just I want to make sure I get it in a lecture that undefined behavior should not be tested. Something I probably should have mentioned. I'll have to get in future semesters, just mentioned in an earlier lecture. This is very subtle, but there's a difference between undefined behavior and edge cases. Edge cases are those tricky cases that have completely defined input-output behavior. Usually these are in the homework spec sheet. The average method, what happens when you have an empty list? What's the average of an empty list? This homework doc said on an empty list, the average should be 0.0. That's an edge case, clearly defined behavior. You know exactly what it's supposed to do. The correct solution on Autolab and your solution, they're going to do the same exact thing. You can safely write a test case for that. But when the behavior is not defined, when you're guessing what the method should do on a particular input, don't write a test case for it. So as much as I like this line of thinking of writing a test case for this and expecting the average to be returned without doing anything extra for the Bayesian average, I like the line of thinking, but you did just guess that that's the behavior that it's supposed to have. You just made that up. So when you have that test case, things are going to break because you made it up. Like, it's undefined behavior. You don't know. Neither of us know what this should return. So it's one of those cases when it's undefined behavior. Don't write test cases for it. You don't write test cases for it. I won't write test cases for it in your task 5 and 6, and we can just not worry about the undefined behavior. It's up to you what you want to do for the undefined behavior, and we just won't test it. Any questions on that? Can we make deadlines midnight? No. No. So the deadlines are effectively Tuesday night. We just give you the extra 9 hours. I'm not going to roll them back 9 hours to make them Tuesday night instead of Wednesday morning. That doesn't make sense to me. I like the get it on my desk by the morning policy. Midnight is so arbitrary of just the clock strikes midnight and you have to stop. It's not like I'm going to start grading it at 12:01. But I do process the extensions, recovery opportunities, expected deadlines. I do process those in the morning. This morning I did all the deadline stuff. I'm not doing that at 12:01. So why not give you the extra 9 hours since I'm not going to use it? So no, that doesn't make sense to me to do midnight deadlines. Midnight's so arbitrary. I don't know why. I know why. It's because students confuse when they see 9 a.m. and they read 9 p.m. Midnight, it's clear that it's by the end of that day. But y'all can read time. Like, I don't have to do that, right? But no, I'm not going to make deadlines Tuesday night. All right. Tip 2. I don't know. I saw this a lot in office hours. I don't know how widespread this is, or if I just got a particular couple of students. But I assume this is widespread for the reasons I'm about to say. When you're testing a class, you have to create an object of that type, specifically because we're testing non-static methods now. I understand why this has been causing some issue. It's because all the test cases for test classes 1 were given to you, and that's where you would have gotten your first practice of testing classes. Admittedly, some of those tests in task 2, you should have had to write yourself, so you get practice with this before task 4, because it kind of puts another concept in task 4. But since all those were given to you, the only tests you've written so far before task 4 were tests for static methods. So I understand the confusion on this one. But when you test a class, you need to create an object of that type first, specifically because there are no static methods anymore at this point in the course. So the intent is that you look at test classes 1, read those test cases, understand what they're doing, and then implement that for your task 4 stuff. I know that's asking a lot. Y'all see that poll, by the way? Don't grade task 4. If I don't grade task 4, none of y'all will do it. I gave you the test cases in test classes 1, and so many of you don't study that. Like, there's no way I can just not grade something. None of you will do this testing if I don't grade it. I thought that was, I don't know. Maybe I should take it more seriously, but I thought that was funny. To not grade it. Like, I can just trust that all of you will write these test cases if I don't grade it. That's silly. Testing, by the way, testing is a core thing that you're learning in 116. You need to understand testing by the time you get out of 116. It's literally a learning objective of the course. So I need to get you practice with testing. Anyway, you need to create an object of that type before testing the code. So look at test classes 1. Test classes 1, every single test in that class, every single test starts with new song, new reviewer, new rating. You have to create an object of the type, and then through that object, you're going to call the methods that you're actually testing. This seemed to fall apart when it came to the comparators, the Bayesian rating comparator and the song title comparator. Students seem confused on what to do there. One thing that is pretty confusing on this one is that the comparators don't actually have constructors. The code that is in the homework doc that you can paste into your code, there's no constructors in those classes. So it's not clear to some way that never came up in lecture yet. It's not clear that you can create objects of those types. If you don't write a constructor, if your class doesn't have any constructor explicitly written, you get what's called the default constructor, which is a constructor with no parameters and no code in the body. So there is always a constructor just automatically created for you, even if you don't create one. So there is a default constructor in those comparator classes. Probably should have made that explicit in the code I gave in hindsight. So you do get the default constructor. So with those comparators, new song title comparator, create your object of type song title comparator, and then call the compare method through that object. I'm seeing a lot of song title comparator dot compare, just like you're testing a static method. It's a non-static method. We're talking about objects and classes. We've been talking about objects and classes for 3.5 weeks now. Got to create an object of that type if you want to test the thing. And tip 3, try not to drive yourself too crazy with this one. I know this one's tough. This one's tougher. Some of you are getting frustrated with the task 4. But I want to shed some light on this, give some brightness to what you're going through. Task 5 and 6, at least in my opinion, I'll qualify this, task 5 and 6 should be less time-consuming than task 4. Task 4 has a lot of stuff in it. It's a beast of a task. There's a lot going on. And I'll maintain, I don't think there's much in task 4 that's necessarily difficult. There's just a lot of it. So many methods you have to test, so many classes you have to test. And it's the first time that you're writing tests before you're writing code. I know that's causing a lot of confusion, and I do expect that because every time, any developer, myself included, first time you write tests before you write the code, it's a weird feeling. It's strange. I understand that. Try not to get too down on this one. When you get to task 5 and task 6, these are going to be significantly less time-consuming. 1, because there's a lot less code that you're asked to write. And 2, you'll already have the tests from task 4. So you'll be writing code with the tests. It'll be like task 2 and 3. You already had the tests, and you're writing the code for it. It makes them a lot easier to write because you write some code, you run the tests. Either the tests pass, you finish your code, and you're happy submitting to Autolab and hoping you get credit. Or the test fails, you run the debugger, you step through, we know what the debugger is now, you step through your code, and you figure out where the bug is, and then you fix it. A lot simpler than just writing the test cases or just writing the code, because you'll have the tests to help you write the code. So it is more downhill after task 4. And there is a reasonable assumption, because it's true in a lot of courses, that the line of thought being, oh crap, if task 4 is this hard, task 5 is going to be this hard. By the time we get to task 9, it's going to be so hard I'm going to be completely overwhelmed and I'm going to crash and burn. That's not the way the difficulty curve in this course works. I don't believe in that progressively increasing difficulty curve. Is that the right way? This way. Progressively increasing difficulty curve. I don't believe in that. I think task 4 is, out of tasks 1 through 9, this is with the exception of the application objective tasks at the end of the semester, out of tasks 1 through 9, I think task 4 is going to hit the hardest. Not to say that it is the hardest or most time-consuming task. I think 7 is going to hit fairly hard, and I think 9 is going to hit fairly hard. But I don't think those ones will be, I think they'll be comparable difficulty to 4, or not even difficulty, but time-consuming. But by the time you get to those tasks, you're going to be such better programmers that they'll probably feel easier than task 4. And I wholeheartedly believe this, if you can survive task 4, if you can make it through this task 4, you're going to make it through 116. You're going to at least get a passing grade. If you can even survive, even if you use an RO or 2 on task 4, if you can survive task 4, I believe that you're going to pass this course. So it doesn't keep getting worse, significantly harder and more difficult and more time-consuming from here. Tasks 5 and 6, like I mentioned, I think those are a bit less time-consuming than 4. And by the time you're done with those, it's going to take us to spring break. You'll have a breather. You can come into the second half of the semester strong and just knock out the rest of 116. So task 4, I think this is the barrier. This is the big filter of that hopefully you all get through and pass. So don't get too discouraged if task 4 is giving you trouble. If you can make it through this one, you're going to be good. And writing tests before, I'm getting this one a lot, and I expect this one because it happens every time. But I want to revisit this one. Writing the test before the code. I know it's weird. I know it's strange. But I'll maintain, I'll say this till I retire, is to write the test without the code. You read the homework doc, you understand what the homework doc is asking, you understand what the input-output behavior is for the methods that are being discussed for those methods, and then you write the tests for based on your understanding of the homework doc and write those tests. As opposed to the other way around where we ask you to write the code other than the test, you do the same thing. If you're writing the code and not the test, you read the homework doc, you understand what those methods are supposed to do, and you implement those methods and actually implement the input-output behavior that those methods are supposed to have. I think those are about the same thing. If you can read and understand the homework doc, you can write the test cases. And if you're having trouble writing the test cases from reading the homework doc, suppose the homework was the other way around and you were just writing the code without the test, how the hell would you write that code if you can't understand what the homework doc is asking and you can't understand the input-output on this input, I expect this output? If you don't understand that input-output behavior the method is supposed to have, how the hell are you going to write that method? I think that's the same as writing the test cases. You have to understand the input-output behavior for either. I know it is strange because it's the first time you're doing it, the first time you're writing tests before the code, which is test-driven development, which is one of the things we want to teach in this class. I know it's the first time, so it does get strange. It does feel strange. But I'll maintain it's the same thing. You have to have the same level of understanding of these methods as if I was just asking you to write the code. But for some reason, if I asked you to write the code and not the tests, there would be much less complaining, at least on that front. So it's strange, but it requires the same understanding on your end. And I would argue a little bit less, because you don't have to know how to actually implement the methods. You just have to know, if I throw this input at it, what should it return? I think that's easier to understand than how am I actually going to get this playlist to sort these songs as I'm adding them. I think it's easier to say, well, if I give it these 3 songs, they're going to be returned in alphabetical order, in this order. That's easier than actually doing the sorting, for example, for that one. Though it can be more time-consuming. I'll give you that one for sure. Writing the tests is often more code and more time-consuming than writing the code itself, the actual implementation. And again, that's true throughout your whole career. There's lots and lots of projects out there. Go look at an open source project with a bunch of testing. It's common for the testing to be more code than the actual code itself. That's just the nature of programming. I'll have some one-line methods where I have hundreds of lines of testing. It's just common. It's part of the game. Is today just going to be about test work? No, but there's room in lecture to have this talk, and I think it's pretty necessary. Would the AO scale be adjusted based on the class grade distribution? No, not necessarily. There may be. Sometimes we do the course eval. You might have seen this in other courses. We might do a course eval incentive at the end of the semester. If you hit a certain percentage response rate on the course eval, we'll change something. But we don't have any plan of what exactly that will be. And there won't be any curve aside from some pseudo curve based on response rates. Potentially, there might not. Last semester, I didn't even do a response rate thing. I didn't even do anything. But Paul and I will discuss it when we get closer to that time, and kind of see if we want that or not. We probably will, since this is the first semester as Java. We probably will really want that feedback, so we probably will give an incentive. Last semester, I didn't do it because it was last semester in Scala. Like, what am I going to do with that feedback? The whole course is changing anyway. So we probably will, but we don't know what that's going to look like yet. One more. This is one I remember. There's one more I would have had it as tip 4, but I thought about it on my way here and didn't have time to do the slides. The incorrect solutions in Autolab are not meant to be reverse engineered. There's it's becoming a pet peeve of mine because over years it's been frustrating me. you're not meant to reverse engineer those. You're not meant to just submit crappy tests or no tests in some cases to Autolab, get all the names of the incorrect solutions, and then try to write test cases for each incorrect solution. That's not the intent at all. I know that happens. I'm not going to stop you from doing that or anything, but I will give you this warning, this caution about it. You're intended to sit down and just write a really good test suite, write really good tests, and then submit. And then in most cases, you'll just knock out all the incorrect solutions because you have a good test suite and not have to worry about the incorrect solutions at all. And then if there is one that you missed, that's the reason for the names. You get this hint, like you wrote a really good test suite, and I'm happy and proud of you and everything, but you did just happen to miss this one incorrect solution. So you get the hint of the name of the incorrect solution. Then you can say, oh, yeah, I didn't do a test for that. And then you can add one test, then move on with that testing. That's the intent. That's the way Autolab's supposed to work with that one. But too often what I see is the reverse engineering. And the cautionary tale I want to get, because I've been hearing about this one a lot, the I forget the name of it, but the can't handle lists of more than 3. I forget the actual name, but the list more than size 3. I've seen so much Piazza, so many TAs coming to me talking about office hours. I've seen it in office hours myself. You see can't handle tests lists longer than 3. You write one test case with a list of size 4, and you say, why didn't that work? Why are y'all doing this? Like, just write good tests, please. I've seen students waste so much time on this by writing one test with list of size 4. You go to submit to Autolab. It doesn't give you points. It doesn't cough up the credit for the task. You go to office hours. You wait for an hour before you can talk to anybody. You finally talk to a TA, and you say, it says more than 3, I have 4, and the TA goes, yeah, I don't know, 4 is more than 3, I don't know what to tell you. And then you don't get a satisfying answer, and you go bang your head across your keyboard a bit, go to Discord and complain, make a Piazza post complaining about it. Just write a test case with a list of size 5 or 6, man. Like, just write a good test suite. Stop doing the bare minimum. When you see can't handle more than 3 and you write one of size 4 and then cross your arms and say, I ain't writing another test. Like, just write another test. You could save yourself hours of time. Just write good tests. The time it takes you to add one more node to that list is negligible compared to the amount of time I've seen students waste. Please respect your own time a bit more. Just write another test. Stop doing the bare minimum on that. It drives me nuts seeing students do that to themselves. Oh, okay, I'm done with all of that. Unless there are questions on Task 4 stuff. That's my stuff that I want to say. I guess one more thing. I have in a previous semester, I might do this again. Don't worry, I won't do this semester. But the incorrect solutions, I should be able to just call them incorrect solution 1, incorrect solution 2, incorrect solution 3, incorrect solution 4. Like, you shouldn't need that information at all. I do give it just for those cases that I mentioned. You have a really good test suite, but you just happen to miss one of the things. So I'll leave it like that at least this semester, but I have to figure out something else in the future. My favorite coding language, I don't know. It depends on what I'm doing. Overall, probably Python, but Python's tough to write large programs in. Okay. Let's move on. That was a little bit longer than I spent on the first lecture, so let's get this going. So let's talk about inheritance. So last time, it's way too long, 28 minutes? Shit, sorry about that. So hopefully some of that helped some of you on Task 4 at least. But inheritance, so let's talk about it. So last time we saw this, we had a class extend another class. Health Potion extends game item, which means Health Potion gets all of this state and behavior from the game item class. And we say that game item is the superclass of Health Potion. And then if we add another method to game item, we saw that Health Potion would inherit that method. So we add this use method. Last time we had a move method, but I can't fit move and use on the slides conveniently unless I go way too small a font, so where a lot of you wouldn't be able to read the slide. So we add this use method to game item, and now Health Potion automatically gets that use method. It inherits it from game item. So Health Potion, if I have a Health Potion and I call .use, I get this implementation of use. So we saw that much last time. And I want to bring up this new scenario. We have inheritance. We inherit the state and behavior from another class, but we don't want all of the state and behavior. There's something that we just don't quite want. And that's where our overrides are going to come into play. So here, when we have weapon extend game item, we inherit that use method, and maybe we don't want that use method. We don't want a method that's just going to use the item. And of course, I'm simulating things with print lines. Again, I can't fit too much on the slides. If you look at the code, there's a player class, and the use method takes a reference to a player, and the player actually uses that item. I just can't fit that stuff. So we're simulating things with print lines. So the weapon says, I don't just want to use the item in the plain way that game item defines. I want some weapon-specific functionality here. So I'm going to actually use the weapon when weapon stuff, actually dealing damage. In the code, this will set the damage that a player can deal to the damage of that weapon. So I want weapon-specific, so I'm going to override that definition. I'm going to override use to be whatever I want it to be in the weapon class. I'm using the override annotation. This is the same syntax that we use to mark our test methods. This @override says, hey, I inherited a method from my superclass, and I want to replace that definition with this definition. So whatever use does, the use method that I inherited, get rid of it, do this instead. So that's what our override is doing. The override annotation is technically optional, but I do recommend, it's one of the things I recommend, that it makes your intentions very clear, and it lets the compiler help you out so you can save some time. So if we don't have the override annotation, this code is identical to what was on the previous slide. This use method will still override the use method in the superclass, but it'll only override it if everything lines up perfectly. So you have to have the same exact name, you have to have the same exact parameter list, including types, and you have to have the same exact return type. And that's what we call the method signature. The method signature has to be identical, or else you don't get your override behavior. This won't override. So in this case, it will override because we have the same name, same parameter list, same return type. So everything matches, and then the method gets overridden. But if anything is off, even by a little bit, your method doesn't get overridden. And this is a tough bug to track down. So if I have a capital S instead of a lowercase s, and I don't use my override annotation, I don't override the method. When somebody calls the use method on an object of type weapon, and I have a typo, that capital S, it's going to call the superclass method. It's not going to call the method that I intended to override the superclass method. I'm going to get the method from the superclass. This is a tough bug to track down because I wouldn't get any errors. The compiler wouldn't catch this because it doesn't know to look for it, assuming the override annotation is not there. And you might not notice for a while. You might even release this software to your end users without noticing this bug. And then eventually you might finally find out that, oh, it was I didn't override the method. It was calling the superclass method, and you get a little bit strange behavior somewhere in your program. That's a bad bug. That's a tough one to debug, tough one to find, because there's nothing yelling at you saying, hey, this is wrong, unless you have, hopefully you have test cases that can catch that, but it's a bit tougher. You have your override annotation, the compiler is going to jump in and say, whoa, whoa. Told me you were overriding something. I don't see any superclass. Like you didn't inherit a method like this. You didn't inherit something with a capital S like that. And then you go fix your code. You get a compiler error. You click on it. It takes you right to the line of code where you messed up. And you say, oh, you look at it for a bit and you say, what's wrong with that? Oh, my capital S. And you hit it with lowercase s and you just avoided a bug. So the annotation can really help, not just helping other developers read your code, you reading your code from the future. Looking back at my own code that I've written, sometimes I'm really mad at my past self because if I write bad code. And the compiler can help you out. Your compiler can be a bro and help you find bugs like this, find those little typos that you have. Maybe you returned double with a capital D instead of double with a lowercase d. It's going to find those issues too and say, hey, you didn't override anything. For what it's worth, Paul is against the override annotation, so if you watch his lectures, he probably won't use this at all. Paul also makes the quizzes, so there might not be override annotations on the quizzes. So just be aware that there are differing opinions. Side with whichever one you want, but side with me because I'm right. Use the override annotation. In the example, in one of the examples today, I won't use the override annotation just to make it clear that it is optional, just in case you see that on the quiz. But override annotation is very nice to have. It helps. It does nothing but help, and there's really no argument against. Like, why wouldn't you do it? It's not like it's a ton of extra work. Paul. So let's memory diagram this stuff. So the big thing that I want to talk about is these two calls of the use method at the end of this main method, and which method is being called. Last time we saw multiple methods being called, and we had to figure out which one was being called. But there was only one of each. So this time we at least have two definitions of the use method. So we have to be a little more careful about what one is called. We have to pay attention to our rules of what method is called a little bit more. So let's go through this code. A lot of this we went through last time, but just very briefly. When we call the weapon constructor, we're going to call the weapon constructor. The weapon constructor calls the super constructor, and we have two constructor stack frames for a single object. Do not forget your superclass constructor. I'll say this a few times this lecture. Do not forget. Nobody in my lectures better forget that superclass constructor. It's the most common mistake on the inheritance quizzes, and it's one of the only things we're testing you on. Don't forget your superclass constructor stack frame. And I got the question a few times, why do we write game item here? It's because game item is the name of the method being called. We always have the name of the method being called there. This gets a little bit tricky. I don't think too much so, but a little bit trickier because it looks like the method being called is named super. So there's a temptation to write super here. It's game item. You're calling this constructor, and you need to put that on your memory diagram to make it clear to us that you know that that's the constructor being called. If we see super right there, it's not clear that you know what is actually happening in inheritance. It's more clear that you just saw a word here and you wrote that word here. Like, come on, anybody can do that. I want to know that you know that the superclass constructor is being called and that the superclass constructor is game item in this example. We need to see all that on your quizzes. So you need to put this. If you want to put game item and super, that's fine, but game item would have to be there if you're tracing through this code on a quiz. And weapon gets all of the instance variables from weapon and game item, since weapon extends game item. Same thing with potion. I won't belabor the point too much, except the superclass constructor stack frame. Don't forget this stack frame. Don't forget that stack frame. Don't forget your superclass constructor stack frame. If I said it enough times, none of you are going to forget that. All right, now let's get to what we really want to talk about today, these two use methods. Weapon.use, where do we look for the method being called? And the procedure is going to be pretty much the same as we saw last time. There's not much different going on here. But let's go through it and make sure we understand the rules of what method is called when we call a method. So we have weapon.use. We're going to look at the calling object. Weapon.use, this is the calling object, weapon. This weapon at 350. It's of type weapon, so we look in the weapon class for the use method. We look in this class, and we look for a method named use that takes no parameters. We find it, and we call it. So we call this use method. This is the one that's called because it matches the type of the object that called the method. Okay, what about potion? We saw this example last time too, except now there are two use methods. We actually have to make sure we get this right. Last time we could have just guessed. There was only one method of each. We knew which one was being called. So let's make sure we get the right one. Potion.use, potion.use. It's called from a health potion. So we go to the health potion class, and we don't find a method named use. We don't find a method named use in this class. We're not completely out of luck here. Instead, we're going to look in the superclass. So we continue our search. We didn't find it here in the class matching the type of the object. So we're going to move on to the superclass. We're going to look at game item and look for a method named use that takes no parameters, and we find it right here. This stack frame shouldn't be grayed out yet. There's a little bit of a typo there. So that use method is being called. So it's the game item use method that's being called when we call use from a object of type health potion. So this use method was a health potion. We just got item used. This use method was from a weapon. We got damage dealt 100. So we called use 2 times. We got 2 very different behaviors because this method is defined differently in these 2 different classes. Weapon overrode the method that it inherited. So we got the overridden method being called. Health potion did not override the method that it inherited. So it called the inherited method. But we start our search in weapon. We don't even have to worry about the overridden method. We never even look at this method that was overridden. We don't care about it at all. We just care that in the weapon class we found a method named use, and we called it. And once we call the method, we end our search. We're not looking for a use method anymore. So we never find this one. Any questions on this one? So we want to jump to, we had these 2 slides that I had to rush last time. If a class doesn't explicitly extend any other class, it implicitly extends the object class. So these 2 classes are identical. These 2 sets of code, this is the exact same thing. Whether game item extends object explicitly or implicitly, this is the same as having extends object right here. If you don't extend anything, Java automatically has your class extend the object class. So when you extend the object class, you get a few methods, some that we aren't too concerned about, but some that we are. ToString and equals are 2 that we've mentioned before, and ToString we're going to talk about quite a bit right now. So every single object in Java, the only exception is the primitive types because they're not objects. Everything else is an object. All other objects in Java have a ToString method because it inherited it from the object class. So let's get back to today's slide. What if we want to change the ToString behavior that we inherited from object? Well, we're going to override it. We're talking about overrides after all. So here's the code from the actual object class. The object class has the default constructor. If this code was removed, it would also have the default constructor. That is optional code, but it does exist in the object class. This is the actual code from Java. I removed most of it. This class is hundreds of lines long, so I just got the relevant bits out of it. But we inherit this ToString method that will get the name of the class, the @ symbol, and then some hex value based on the hash code of the method, of the object, which we can override the hash code method as well if we want to change this behavior, but more likely we're just going to override it. So health potion extends game item, which gets all the state and behavior from game item, but game item also extends object implicitly, so game item gets this ToString method. So if we call ToString on a health potion, we do our search the same way that we did before. We look in health potion for a ToString method. We don't find it, so we continue our search in the superclass. We look for a ToString method. We don't find it, so we continue our search to the next superclass, and then we do find a ToString. So if we print out our health potion and weapon right now, we'll get that default behavior that we inherited indirectly from the object class. And this is what I got. You'll get different hex values if you run this code. But this is what I got when I was making the slide and I ran the code. Just some randomish hex value, random to us hex value. So that's the default behavior. But the default behavior is pretty useless. We saw this earlier in the semester. We just printed something out, we got this, and it's useless. Even the official documentation from Java says it's recommended that all classes override the ToString method. So let's override this thing. So we can go to game item. We're going to use our override annotation, override ToString, and replace it with whatever we want to be returned when a game item is printed to the screen or whenever it's converted to a string. So we have our overridden ToString. We did this earlier in the semester without our override annotation. We were just careful to have toString with the capital S, no parameters, return string. We were just very careful to do that, and we were actually overriding the inherited method, but we didn't know about inheritance yet, so I didn't use the override annotation or talk about inheritance. Now we do know about those things, so we're talking about it. So we override that toString, but that is what we were doing earlier. So we override the toString, and now weapon and health potion inherit the overridden toString, and they never continue their search to the object toString to see that method. They just get the game item toString here. And usually we want our classes to have specific behavior for that class. So we'll have weapon and health potion both override toString. I'm mixing my annotations here. I'm leaving the annotation off here by having it here, just to drive the point home that the override annotation is optional. I just recommend it because it does nothing but help you. And then we have this little guy here. Super, we saw using super to call the super constructor. We can also use super to call methods from the super class. So if we're overriding the toString method, we can still call the method that we're overriding by using super.toString to call this method. This is a very common pattern in programming. It often is the case that you don't want to completely replace a method with an override, but you want to add functionality to it. So to add functionality to a super method, we'll override it, but also call it, so we get its behavior and then just add extra behavior on top of it. Very common to do in programming. Let's see this in action. When we see this system.out.println, println will call toString. So be careful, don't miss this on your quizzes if you get a quiz like this. Println will call your toString. So when we say println weapon, we are calling toString on that. This is a bit confusing because I always say if it's internal to Java, we don't trace it. And that's true for the println. We won't make our println stack frame. But println will call toString, so we do have to call the weapons toString. To find that, toString was weapon.toString. That's a weapon. toString, easy enough. For health potion, we go health potion.toString. And then the health potion toString, we do find one in health potion, is